Hey guys, on to the second core practical then. Today we are going to be looking at chromatography. The equipment for chromatography is really easy. You just need some coloring pens, whatever thing you're going to test or whatever. I'm choosing pens, but I guess this could be dyes or I've done this with Smarties or something before. Whatever the question says is, these are the things that you're putting on the chromatogram, right? Here we're going to make a chromatogram. The chromatogram is made from a piece of filter paper that is cut into a sort of oblong shape, and it's connected to a little wooden splint that has been paper clipped to the top. So obviously this will then go into our beaker. Here we go, and it should be able to stand up of its own volition. So this is perfect because it hits the bottom and it stands up nice and straight. So that'll be really good for doing my chromatography in. We're going to use a solvent. Solvent for this one, we're going to use distilled water. And finally, you need a pencil and a ruler. These are absolutely essential, so you need to make sure you've got one. Okay, first of all, maybe about 1.5 centimeters up from the bottom. You don't need to be precise about this. We're just using it as a baseline. You want to rule a line. But unfortunately, I need 2 hands to use a pencil, so I'll be back in a bit. Okay, I've just ruled this pencil line. So this will be where I put all my samples for my chromatogram. I decided I'm going to put 2 different chemicals on this chromatography. I'm going to use this blue and this green from the same set, and we'll see what happens. Okay, when you're doing this chromatography, you want to very, very carefully just dab very gently on the paper, let it dry, and dab again. And you want to try and make a very small but very concentrated spot. So let it dry each time. Don't let it soak into the paper. Just dab it very gently on the paper. You want to make, like I said, you want to make a very small spot, but very, very concentrated like I'm doing here. Probably going to dab it just one more time. Here we go, just letting it dry and dab. Okay, I have repeated that with the green ink as well. And just make sure you add labels because I promise you, you'll forget which one's which. Okay, I'm just adding some water in the bottom, enough to get the bottom of the paper, but not enough to go over the line. So you can see there that the water level there definitely hits my paper, but does not hit my pencil line. So that's great for this reaction. Okay, so now we can watch this chromatography happen. You can see here that the water is starting to soak up the paper, and hopefully if we leave it for a while, we can see kind of what's going on. Already you can see that the green one is starting to separate into different colors. Seems to be a yellowy, greeny dot at the bottom and a really light blue color at the top. And look, the blue color seems very similar in color to the blue ink that I used in my blue pen. See here, I've set up another chromatography in exactly the same way, but this time the colors I'm using are brown and black. Dark colors can kind of be a little bit more interesting when we do chromatographies on them. So let's see what happens here. You can see the brown is already starting to bleed quite significantly. We are about halfway through the chromatogram, and you can see that the blue ink is kind of all staying together as a single big blue dot. But look, my green ink is starting to separate out into 2 separate colors. That's really interesting, and we'll have a look at why in a bit. We're about halfway through for my darker colors, so you can see here that actually I've got a blue color, which is very similar to the blues that we saw in the lighter colors, the blue and the green. But look, we've kind of got a bit of a purpley red color going on in here, kind of melded together with this sort of yellowy color right at the bottom. So we've got a few different colors here in the brown, maybe about 4 different colors, I'd say. Like you've got that light blue, kind of a purple, a kind of a reddy orange, and a yellow. The black, however, hasn't moved at all. So that's very interesting. We'll have a talk about why that has happened later, but maybe you want to come up with some ideas whilst you watch the video. Okay, this chromatogram is near the end of its life, so I'm going to remove it just shortly, and the same for over here. So let's just remove these 2 now. When you've removed them, what you want to do is get your pencil and just draw a pencil line over where the solvent got to, just so you really know what you're looking for. And then just circle around any spots that you can see. So I've kind of got a greeny yellow spot here and my 2 blue spots, which are almost identical. See, for my brown here, I've actually got 4 different colors. We've got this blue here, which is very similar to this blue here. We have sort of a purpley color up here, sort of a red, and then an orangey yellow down here. The black just stayed at the bottom as a single spot. We want to measure how far the liquid got to. So this went, what's that, about 3.8, 3.9-ish centimeters. And then you want to measure from the middle of the spot how high it went. So this one went 3.5 centimeters. For all of your experiments, you want to write down what the distance of the solvent moved and the distance that the spot moved. So this distance of the solvent was 3.8 centimeters, and the distance that the spot moved was 3.5 centimeters. Now, we want to calculate the RF value for this experiment. So the RF value is equal to the distance of the spot over the distance of the solvent. So to calculate the RF value for this blue ink, we're going to do 3.5 divided by 3.8. So we're going to write down it's going to be 2.6 centimeters. And then we just want to calculate the RF again. So we do 2.6 centimeters this time over 3.8. Right, what's the answer going to be? Now rounded up, that is 0.92. You want to have yours in about 2 decimal places for your value for RF. This is actually the same for every single one of my blue values. So what you need to do is calculate the RF value for each of the different inks that we have. But over here, we had 2 different inks arrived. Now, this blue ink here is going to have exactly the same RF value. They're the same, exactly the same substance. But this sort of yellowy green ink, that is going to have a different RF value. So, recalculate, find the center of the spot, and read on here what it's going to be. So it's going to be 2.6 centimeters. Rounded up, that's going to be 0.68. Notice how I don't use any units here. This is centimeters and this is centimeters, so they cancel out. So let's describe these inks. This blue ink has only got 1 spot. That means it's a pure ink. There's only 1 substance inside this ink. But for this green one, we've ended up with 2 spots. There's a blue spot and sort of a green spot. Those 2 different inks make up the green ink. So this is a mixture of inks. For my brown, that's a mixture of even more inks. We said there were about 4 different inks in this mixture. But this black one, that isn't pure. What's happened here is this hasn't dissolved. It is an insoluble ink. So if you find that the RF value for an ink is 0, it doesn't mean that it's pure. It means that there is nothing, it means that it won't dissolve in your solvent.